Imagine a dark, massive void moving towards our sun. This is no ordinary celestial body. It is a black hole, a region of space and time where gravity is so strong that even light cannot escape. What if this black hole passes through our solar system? How will our planets, bound by the sun's gravitational force, face this cosmic intruder? Will humanity survive this cosmic catastrophe, or will we be erased from existence? Let's dive into this terrifying yet fascinating scenario and see what could happen. As the black hole approaches our solar system, its gravitational pull starts wreaking havoc on our planets. The orbits of planets, stable for billions of years, become disrupted. Some planets may be pushed towards the sun, while others could be flung into the cold, dark depths of space. Earth, our home, will not be spared from this gravitational turmoil. Our planet could wobble on its axis, leading to catastrophic climate changes and devastating tidal waves. One of the most intriguing aspects of a black hole is its ability to distort space and time. This distortion is so powerful that it can alter the very fabric of our universe. As you approach a black hole, time slows down and strange changes begin to occur in space. According to Einstein's general theory of relativity, time and space are two aspects of the same fabric. When a massive object, like a black hole, affects this fabric, it distorts both time and space. A massive object, such as a black hole, can bend the fabric of space-time around it. This bending is so intense that it can generate gravitational waves which travel through the universe at the speed of light. Imagine placing a ball on a stretched piece of cloth. As soon as the ball is placed on the cloth, it sinks down, creating a depression. The ball creates a depression in the cloth. Similarly, a black hole creates a deep depression in the fabric of space-time. A black hole does the same with space-time, creating a gravitational well. This well is so deep that anything falling into it, even light, cannot escape. This creates a gravitational well from which nothing can escape, not even light. This gravitational well forms an event horizon around the black hole, a point from which return is impossible. As a black hole passes through our solar system, it bends and stretches space-time along with it. This process is so powerful that it can alter the orbits of planets. It bends and stretches space-time, distorting our understanding of reality. This distortion is so profound that it can completely change our perception of time and space, distorting our understanding of reality. Understanding this cosmic dance of the black hole gives us an opportunity to learn more about the deep, mysterious forces of the universe. Although black holes are often seen as consumers of light, they are not entirely black. In fact, black holes possess a mysterious quality that makes them even more intriguing. In 1974, physicist Stephen Hawking proposed that black holes emit a faint radiation, now known as Hawking radiation. This discovery was a significant turning point in the field of astrophysics. The theory of Hawking radiation suggests that black holes are not entirely stable, but instead slowly lose energy. This radiation occurs due to quantum mechanical effects near the black hole's horizon, a complex and mysterious process. The event horizon of a black hole is the point of no return. It is the boundary beyond which nothing, not even light, can escape. Hawking radiation is generated near this boundary, where the laws of quantum mechanics and general relativity meet. Hawking radiation is incredibly faint, and observing it directly is a challenging task. Scientists have used highly sensitive instruments to measure it, but it remains a mysterious phenomenon. Studying Hawking radiation provides us with a deeper understanding of black hole behavior and their role in the universe. It helps us understand how black holes evolve and how they might eventually end. Scientists believe that through Hawking radiation, black holes gradually lose their energy and may eventually evaporate. This process is extremely slow and requires highly sensitive instruments to measure. Nevertheless, it has a profound impact on our understanding of black hole behavior and their role in the universe. Studying Hawking radiation helps us understand how the universe works and the role black holes play in it. It is a mysterious and exciting field that helps us uncover the deep secrets of the cosmos. Section 5. Tidal Forces. Stretching the solar system. As the black hole passes through our solar system, its intense gravitational pull will generate tidal forces. These forces will be so powerful that they can distort the planets and moons of our solar system. Tidal force is the difference in gravitational pull on one side of an object compared to the other side. When a massive object like a black hole comes close, this difference increases, causing significant changes in the structure of planets and moons. In the case of a black hole, these tidal forces will be extreme, leading to the spaghettification effect on planets. Spaghettification is the process where an object is stretched and elongated until it forms a thin, noodle-like structure. Imagine a ball of dough being stretched and elongated until it forms a thin, noodle-like structure. This process can also happen to planets and other celestial bodies when they come under the extreme gravitational forces of a black hole. This is the fate awaiting the planets in our solar system that wander too close to the black hole. As they approach the black hole, their shapes will become distorted, and they will eventually break apart due to the stretching. It will be a catastrophic event, but it can also teach us a lot about the incredible and terrifying forces of the universe. Upon nearing the black hole, the ultimate fate of the planets will be to be consumed by it. This process helps us understand how powerful and destructive events in the universe can be. It also teaches us the importance of protecting our solar system and the need to learn more about these celestial events. Section 6. A Glimmer of Hope, Harnessing the Abyss. Despite the destruction associated with black holes, is it possible that humanity could somehow benefit from this cosmic event? One idea is the concept of tapping into the rotational energy of a black hole. Extracting energy from a disk orbiting around a black hole is theoretically possible, a process similar to creating a massive electromagnetic generator around a black hole. However, such an endeavor would require technology far beyond our current capabilities. Section 7. Escaping the Clutches, a Cosmic Exodus. If a black hole becomes a significant threat to our solar system, humanity's only option might be to migrate to another star system. For such a cosmic exodus, we would need a significant leap in our understanding of interstellar travel. We would need to develop spacecraft capable of traveling at a significant fraction of the speed of light, as well as technology to sustain a large population on board. While these challenges are daunting, they are not insurmountable for human ingenuity and the will to survive. Section 8. The Aftermath, a Transformed Solar System. Once the black hole passes, our solar system will be changed forever. The orbits of the planets could be permanently altered. Some planets may be destroyed, and others could be thrown into interstellar space. The Sun, our star, will also be affected by the encounter with the black hole. It could be stripped of some of its mass, or it could be set on a different trajectory. The long-term consequences of this cosmic event are mind-boggling. Section 9. Conclusion. A universe of possibilities. A black hole passing through our solar system would be an awe-inspiring and terrifying event. While it would pose unprecedented threats to our existence, it would also advance our understanding of the mysteries of the universe and the limits of human capability. As we continue to explore the vastness of the cosmos, we are bound to encounter wonders that challenge our imagination and force us to question our place in the universe.